Welcome to the Job Shop Show, where we talk with the owners, suppliers, partners, and customers of custom manufacturers. Listen and learn the secrets of top-performing job shops, the tools, techniques, and backgrounds that have made them successful, all in the quest of raising the bar for custom manufacturing. I'm your host, Jay Jacobs. This episode is sponsored by Paperless Parts, connecting buyers and suppliers of custom manufactured parts. The Paperless platform is a secure, ITAR-compliant, cloud-based manufacturing system for suppliers that reduces the amount of time spent on sales, estimating, quoting, administration, and order processing. It offers seamless integration with the accounting and ERP software tools that shops already use, such as QuickBooks, E2, and JobBoss. Paperless Parts was founded with a mission to make manufacturing more accessible by streamlining the quote-to-cash process. Spend less time quoting and more time selling. We are back with a treat for you today on the Job Shop Show. Jay Jacobs here with Ali Bahar of Mammoth Machine in Huntersville, North Carolina. Huntersville is located just outside of Charlotte. Mammoth has a specialty of reverse engineering old, often undocumented out-of-service parts as well as common wear items, and then reproducing them by manufacturing new ones from the created data. Welcome to the show, Ali.
Hey, Jay. Thanks for having me. It's a pleasure to be here.
Yeah, I'm glad you were able to make the time. I want to jump right in. I'm really interested in how you reverse engineer at Mammoth, some of your capabilities, because scanning technology, it's been around for a while, but it's certainly not mainstream, and I still think of it as more of an art than a science. So can you tell me about what Mammoth does, what your approach is?
Yeah, so, we look at every project and situation as its own unique challenge, and we gather as much information and data as we can about the component or assembly or the project as a whole, and we strategize a plan or path forward, if you will. And it's reverse engineering is as much of an art as it is a science. There's some subtleties, there's a lot of skill required in the CAD side, but then on the engineering side, you kind of just need to approach things as an engineering challenge, as you normally would. You need to look at the whole thing and understand the end goal and manufacture your method forward based on that.
Mm-hmm. So let's go through step-by-step a standard project. Someone brings a part into you. What happens?
So if it's just a part, it's a common part, maybe something like the Lovejoy coupling is a project that we did for a client of ours who was in a pinch, and they needed this common part that you could normally pick up at a hardware store or a specialty supplier, pretty quickly. Theirs happened to be very particular, and it was 12 weeks out from Germany to have it delivered, and this was a key component of their main production line. So
their line was down?
Yes, yeah, the line was down. Their main line was down, and so it's a perfect example of someone coming in a pinch. Go ahead.
Did they quantify for you how much that cost them per hour by having the line down?
No, that would be awesome. That would be too easy, right? If our clients would do that, that would be great, because then we could do the value add. We could determine, the best method forward for the cost savings. But more often than not, the people that we're dealing with aren't privy to that information, and the ones that are, they like to keep that close to their chest, understandably so. So in this particular situation, it was in a pinch. It was the maintenance engineer that was there that evening that was working to find out why the line was down, and then was tasked with getting the line up as soon as possible. Mm-hmm. And in this case particularly, he had to work through the night, into the day, whatever it took to get it back up again.
Okay. What happened next?
So he called us. It was it was end of business or end of first shift for us that day. He called us around 6. we were still here working late as we usually do,
Mm-hmm.
and then he asked if we could help him in this particular scenario, and with no prints or CAD or anything to relate to, we just asked for him to come in since he was local to us. So he came in, brought us the part, explained to us the situation, what had happened, and what he's running into with the replacement parts that he had sourced, and the challenges that he was facing. So we sat down with him and did a quick engineering review and tried to determine the best path forward. Were we better off modifying an off-the-shelf component to work for their particular application, or building something from scratch, or modifying the broken component to get them by? So after we went through this quick decision tree, if you will, to determine the best path forward, we decided that we have the scanner. We can quickly and easily reverse engineer the good half of the coupling, and then, but in doing so, we could replicate the bad half and the assembly features necessary to make this to the drive unit. So once we cleared that with them, and we had a plan, and he had cleared that with his team, then it was off to the races. It was get it done as fast as possible.
Okay. So the part itself, it sounds like it was either broken or had wear on it, because you said there was a good half. Is it something that you were able to, you knew once you had the data you could mirror image it or copy over? How did, tell me, because thinking about this, if you have an old used part that's coming in, it's not probably to the geometry specifications of when it was originally manufactured. So how do you think about that as part of the project?
So in this particular situation, because a Lovejoy coupling has what you call a spider in the middle, and it allows for power transmission from one end to the other. Through the spider, the one half of the coupling had sheared off. The other was still good, was still actually in pretty good shape. So because of that, we were able to actually 3D scan that half, and reverse engineer it, mirror that to replicate the other half, build a small assembly to make sure everything meshes well, and we've captured all the details, and then we could replicate the bad half, and go ahead and get that on the machine.
So I jumped ahead a little bit. So you got the part, the physical part in your hands. They said go. Next step.
So next step was, we knew roughly what size raw stock we needed, and and one of the guys ran around and gathered the raw stock, started prepping it. Another person was on the scanner, started scanning the part and prepping the mesh, and then someone was prepping the machine, getting it set up for the part, because we knew that the general geometry of what we're going to be machining, so they were able to go ahead and determine what we would need. So everyone was working in correlation, because this was a rush job. So it was move as fast as you can. So but the steps were, we 3D scanned it, and then prepped the mesh, and reverse engineered it, which turned it into a solid file. And then with that solid file, we were able to build the assembly. So we had both halves, right? We had both halves, the receiving and the transmitting half of the transmission coupling, and then we were able to drive the spider in between the halves, and then after that, it went straight to toolpath, got programmed, and then thrown on the machine. And then so another part of the challenge was that spider is made out of rubber, so we had to determine the kind of rubber it was made from, and then make that part as well. So we determined it was made out of 90 durometer rubber, and we just happened to have that material for our Formlabs SLA printer. So we actually 3D printed the spider out of the rubber-like material while we were machining the part. So we started the print on the spider because that was going to actually take longer than CNC machining the parts. And then by the time the parts had come off the turning center in the mill, the spider was done. We cleaned everything up, put it together, checked for fitment, and we were good to go. We made two spiders just in case because the 3D printed. We didn't know how well the 3D print would stand up to abuse. They're not. It's not known for being able to handle that amount of impact, if you will.
Right, but at least it got the line up and running, and then it was at worst case a temporary solution. Best case, it was going to function for a while. You just didn't know. So
absolutely.
So let's really get into some of the details here. What type of scanner do you have?
So we use a Faro Edge scan arm with a HD laser line probe. It allows us to 3D scan and do point probing like a CMM, like most of these arms are known for. Doing so allows us to do contact and non-contact measurement on various geometry. So
you can both laser scan and contact measure in the same device?
Yep. Yes, sir.
And why would you choose one technique over the other? Or do you use them together?
So arguably the laser scan, the non-contact, it's plus or minus 20, 30 microns at best. And then you have to deal with surface geometry, texture, reflection, all these different things, which you can deal with. And for freeform, there's not much better than that. But the probe lets you get, contact point probe accuracy, within the, 10, half a thou, if you will. There's some standard deviation to that, but it's fairly repeatable. You don't have to worry about the mesh and managing the point cloud. So if you're just pulling orthogonal features or just need a specific geometry, or you just want to identify a plane or a cylinder, the point probe has been great. It's quick, it works well, it's easy, and it's reliable.
Mm-hmm. So can you use them together where if you had a surface that you definitely wanted to laser scan, but the edges you could use the contact to be very accurate on the constraints?
Absolutely. We often use them together. Best use case is for automotive components. So if you're doing like a head or a valve cover, mm-hmm. you probe the geometry for location for bolt holes and pins, and then you could scan the rest for clearance, and then you could model off of that, knowing that your scan is only needed to clear rockers and cams, and then but the holes have to mount up as close as possible.
Perfect. And what does a Faro scan arm cost?
It can vary. I think I can't remember what ours cost, but roughly I think they're just over $100,000 with the laser line probe. They don't make the scan arm anymore, so the Quantum is the replacement, and I think mm-hmm. that's the price. You'd really have to contact your local rep for pricing.
Sure, but that gives us a rough ballpark of it's not $10,000 and it's not $500,000.
Right.
So the video that I watched on engineering.com, and I thought that was a fantastic video that they put together of Mammoth Machine. Looks like the Faro scan arm is portable, so that you can use it on a surface plate, but you also can take it on site. Is that correct? Or move it around your shop as needed?
That is correct. Yes. It's right now it's stationary on our granite bed or mm-hmm. or a large granite slab, but we can absolutely deploy it on site, and we have for more than a few applications. For automation, when we do automation retrofits, we'll use it to go on site and be able to pull hard mounting points for equipment right there on a piece of equipment, old piece of automation equipment that may or may not have CAD files, mm-hmm. or may have CAD files but may have been changed after it was installed and then used. And a lot of times this automation equipment gets modified, after within a year of use.
Right. So how long for this one project you talked about, how long does it take to actually scan the parts?
That's tough to say. It really is dependent on the part. So, and the level of accuracy we'd be attempting to achieve on the part. So it can be as short as 5 minutes for a really small, or not even small. The size is relative. The main thing is going to be how many features are there? What are you trying to capture? What level of precision are you attempting to achieve in the scan? So it can be as short as 10 minutes. It could be as long as 10 hours. I mean, we've done scans from everything in between.
Okay. And you threw out some numbers before in terms of accuracy, but I know that there's different ways to define accuracy or precision for scanning. So can you talk about that a little bit?
So the scanner is rated to plus or minus 20 microns accuracy, but it's a surface tessellation, and that accuracy is point to point in the point cloud generation. So the accuracy is once again relative when it comes to blue line scanning. It's all dependent on the texture and the surface geometry and how reflective it is. We've been able to reverse engineer parts that were verified down to 3 micron of repeatability utilizing the probe and the scanner.
Wow.
That very well may be best case. And then, if we were reverse engineering some foam parts or fiberglass, the accuracy is well within the tolerance of fiberglass, but it just depends on the surface geometry. And if you're using so like carbon fiber, it shows up kind of choppy depending on the carbon fiber, whether it's a matte or a weave. So the material really has a big impact on that.
Does color impact it at all?
Not so much the color, the opacity of the color. So white Delrin is a unique one because it absorbs so much of the light and it blurs the line. It makes it hard to scan white Delrin.
And it's tough to throw something on Delrin to make it a different color.
Exactly. So we've reverse engineered quite a bit of Delrin, and it's funny. Sometimes we'll just have to use Sharpie to get it to reflect light. If we can use the probe, we'll use it because it makes it easy. But yeah, in some cases, we'll have someone in there sharpieing a part.
That's funny. And so you use the scanner. What does Faro provide software that the point cloud is coming into, or now we're going from the physical to the digital? What happens at that stage as the scanner's capturing the data points?
So Faro does provide some software. We in-house personally, we use Geomagic. It's worked well for us. It has a lot of strong tools for reverse engineering. So we'll scan directly into Geomagic from the ARM, and then we'll proceed to clean up the point cloud and create mesh data and merge this mesh data inside Geomagic, at which we'll then align it to the global coordinates and then move forward with reverse engineering. So
you use the term mesh. Is the part just one big mesh? Are there multiple meshes?
There are multiple meshes from the scan, and then we'll compile them all to generate one big mesh, so it's easier to work with. But before they're even meshes, they're points. They're just raw points in space. Right. So in Geomagic, we can scan straight to mesh, so it's generating the mesh as we're scanning. But in some cases, it actually makes sense to just pull in the point cloud data and then convert it to mesh afterwards.
And what cases would make sense for that as opposed to just scanning directly into mesh?
Maybe something that's textured that you'll have a tough time working with the mesh. So you want to pull in the point cloud data, and then you can set a filter to filter out the noise or the highs and the lows, and kind of take the median.
Mm-hmm.
That's one, or it might be something where you're working in a confined space, and you really have to, or actually a better case is a really large object where you're really taking in a whole lot of data, trying to maintain a tight accuracy, and the data is becoming unmanageable for the software. Then you'd rather run that in mesh or run that in point cloud and then convert to mesh afterwards, because the software will have a tough time keeping up with it, or at least in our case it has with the hardware that we have.
So when I hear the term optimized mesh data, is what you just spoke about, does that reflect the term optimize, or is that something different?
Kind of. Optimized mesh data is typically where you'll take a existing mesh and reduce tessellation to go from 10 million points to maybe 8 or 5 million points, and then it's a feature or function of Geomagic. I think maybe in the broader sense, it may be used to clean up existing mesh to make it more manageable.
Okay. And how big are these files?
They can be gigabytes. Absolutely. We work with regularly. We work with 1 to 2 gigabyte files, sometimes up to 10.
So on the McLaren deck lid that you did for hypercar development, how big was that file?
That one was about 3 gigabytes. So when the scan's coming in, we can actually modify or rather set the settings of the scanner to take a broader scan. So it's not importing as much data. The smaller parts, actually, some of the really high precision small parts we do are bigger data sets, because they'll be 30 or 40 million points.
Mm-hmm. Okay. And you have this in Geomagic. What is the file format that you are saving in Geomagic, how do you get it then into the CAD system?
So Geomagic can export direct to most CAD systems, or you can save as a universal file like STL, Parasolid, IGES, STEP, any of those standard universal files to import to CAD. But the Geomagic's import to CAD feature works pretty well.
What do you like to use?
I personally like to import as a universal file, because we use SolidWorks as our primary modeler here in-house. And when you import from Geomagic and it pulls in the tree, it can actually make it a little confusing moving forward. So we'll just bring them in as imports and just modify them in SolidWorks.
What sort of things do you have to think about as you're working with the data then once you get it into SolidWorks, as opposed to designing a part from scratch?
So you lose your reference and your datum when you go to SolidWorks. I mean, your global position is saved, so you can take a SolidWorks file and export it back into Geomagic if you need to compare to scan. But once you're in SolidWorks, you're really going to want to move forward in SolidWorks. Going backwards may misalign certain objects or features, and it could leave subtle deformations, if you will, that you may not catch until manufacturing.
Okay. Do you have any other examples of scanning projects that might be useful to share some of the steps or challenges of reverse engineering a part?
Yeah, I mean, they're it's hard to explain. So like I said, it goes project by project. We use the scanning and reverse engineering as a tool in the grand scheme of what we do. the most recent one we've done was a reverse engineered a transmission for an older machine, piece of automation equipment,
Mm-hmm.
where the transmission had failed and there was no replacement, no CAD or no print. So in this particular case, uh, we wouldn't use the scan data to actually replicate the gears, like the helical gears or the bevel gears. What we used the scan data for was to compare to. So so we were able to and to determine the pitch, the diametral pitch of the cross plane helical gears. So we were able to use the scan data to to build the actual gear set for the replacement part, because normally you would have some kind of a gauge for a spur gear or involute gear to be able to take this data and replicate it.
Mm-hmm.
But with the cross-plane helical gear, it's kind of a challenge because the mating, it's a gear set, they're manufactured in a set, and they mate together, and their pitch is unique to each other, and the rotation. So when we design these, we have to design them as a set, determine the difference between the two, and really engineer them from scratch for their application. And it was unique to any gears that we've seen or worked with before. But it was having the scanner and the technology was an invaluable tool for us at that moment, because it would have been almost improbable to make these parts otherwise.
And then you machine those in-house?
No, actually, we sent these out to someone who specializes in gears because they were so unique. The pitch and the way that
Right.
they were manufactured wasn't something that we were comfortable making in-house, since we had no experience doing that before in the past. So we can replicate anything, but we won't always create it in-house if we don't have experience manufacturing it. We'll lean on someone who is better suited for that.
Sure. At Rapid, I had a rule that we did not machine or manufacture any gears because there are so many intricacies with gears. It's definitely a specialty, and you either know how to do it or you don't. So.
Right. There's so many little subtleties in those gears.
Mm-hmm. So I jumped into asking about this scanning capability of Mammoth Machine, but let's step back. Can you tell me how Mammoth Machine got started and why? What was the purpose of how you got started? And I understand you have a co-founder, so maybe you could share how George Brinzi, you guys came together.
Yeah, absolutely. So George Brinzi and I are neighbors. We've known each other for over a decade. So we would always hang out in the garage and work on cars and motorcycles and what have you, just on a Friday night. And I was working in engineering on the product development side, and George was actually taking a product to market in on the tactical and police force side. Mm-hmm. So it was cool because we were at that time, we were both on opposite ends of the same problem that is common in manufacturing or in the economy today. So we would often talk about the challenges that I would face on product development and the process of manufacturing and production, whether it's mass production of components or prototype parts. And he would talk about similar challenges that he was facing as an inventor, taking an idea to market, and the challenges of getting a part mass produced and getting prototypes and getting the engineering done. So we would always talk about that, and we would determine that there has to be a better way to move forward. We figured between the both of us that we've encountered enough challenges to try to solve the problem. So it was the right time, the right place, the right opportunity to where we moved into starting what Mammoth is today, and we've slowly been building this business. And when we started, our goal was to take our own products to market, and we had actually worked heavily in automotive and auto sports development. We'd built supercharger kits and all kinds of performance parts for everything from supercars to just regular daily drivers.
Okay.
But in the end, we decided that the equipment we had and the knowledge and what we could provide better value, and there was more of a problem present in actual manufacturing than the development side. There's a lot of people working towards development because it's the sexy thing to do, if you will. Everyone wants to be a part of that, but nobody wants to solve the problems that are present in true manufacturing, where things are made in mass quantities. So we've been fortunate enough to work with a local company and kind of work with their engineering team and help them out through several problems and projects that they had, and learned about the industry and kind of got our start that way. And it's been just growth from there. What we focus on is providing components, support, engineering to large-scale automated manufacturing in any way we can. We want to help ease their burden because we know that right now there's a big shift in manufacturing as there's a higher demand and a higher demand for efficiency.
The name Mammoth Machine, how did you come up with that?
I wish there was a great story behind that, but in reality, we were just coming up with names and things that we liked, and we liked that the mammoth represented a force. The mammoth was a symbolic animal and it also meant to be big and do big, bold things. So we thought it would be a great symbol for us moving forward.
Are you familiar with the Mammoth Genome Project?
I am not.
So it struck me with your focus of being able to essentially bring parts back to life, old, obsolete parts, which is what the mammoth is. It went extinct about 60,000 years ago. And there's a project headed up by a guy named George Church out of Harvard and being done primarily at Penn State University, where they are trying to bring the woolly mammoth back to life.
That is awesome.
So the name of your company just struck me as I wasn't sure if that was deliberate and a play on what they are, in fact, pretty far along the way of being able to do. And is a great encapsulation of what I see as I know you have other skill sets and capabilities in your shop, but there are so many parts out there from companies that have been merged into other companies that have been merged into other companies, and the documentation just doesn't exist anymore for the parts, but there's machinery that's been in service for decades, and parts break, parts wear. And you guys are really experts at bringing those parts back to life.
That is an awesome point. And we would love to kind of adopt that philosophy behind the name. And it is absolutely what we do. Our part obsolescence is at our core, is a staple at our core. And, we think it provides the most value to manufacturers who are kind of stuck in a way where these machines are their lifeline, and in some cases there are no replacement parts. And these things have been running for, like you said, decades. And when they go down, it's a scramble to even get the machines back online.
Mm-hmm. Yeah. So you have Mazaks in your shop. Why Mazaks? What attracted you to bringing that equipment in-house?
So I've worked with Mazaks for a couple years now, maybe 5-6 years, maybe a little longer. and the service has always been impeccable, and the quality is bar none. So we started with a Haas,
Mm-hmm.
but what we found as we grew is that we wanted a brand that we felt comfortable growing with, and I felt like we wouldn't be able to outgrow Mazak. That their support and their quality and level of machine would be able to keep up with us or exceed our capabilities for years to come. So that's why we went with Mazak. We got our first Mazak and our second one shortly after that, and since then we've been buying just Mazaks, and the quality has been great. We had a warranty call. The guys were here within 6 hours. That's unheard of in this industry. So we were pretty pleased with our equipment.
Is your philosophy to buy new or used equipment?
We prefer to buy new if we can. Things don't always work out that way. Sometimes there's a deal just too good to pass up, and you have to buy used. But when we can, we buy new. The new machines we have really have come onto their own. Like our newest Mazak has thermal compensation. It holds microns tolerance. It is incredible. It is an incredible piece of equipment that is really able to maintain stability and reliability throughout its life. So if we can, we'll buy new, but sometimes it makes sense. We have a piece of used Mazak equipment as well, and it's been great.
So talk to me a little bit about you called it thermal management, or what is the machining center doing in that scope?
So I couldn't necessarily talk to you about the science behind that, but it's essentially accounting for thermal growth of the machining center. So it's not going to account for thermal growth of your part, mm-hmm. but it can map the thermal growth of the machining center as it's in use. So as long as your part's not growing, theoretically it can produce the same cut at the same distance from the part every time. Now, it's not going to compensate for the growth of the vise or your subplate or your part, but it will compensate for the growth of the machine. And people don't often think about these machines growing as they run or as the temperature changes in the shop. But when you're making parts to microns, it really does matter.
So if you are in particular running production of parts and you start out in the morning and it's cooler, assuming your shop perhaps is not climate controlled, but as well the machine may be cold and you want part-to-part repeatability to be dead on, particularly if you've got some real precision parts you're manufacturing. So that is a very cool feature. I'd heard about that, but I wasn't aware of how dialed in it was.
Yeah, so we have a turning center that doesn't have it. It's the used piece of machine we bought. It's great. I've been running these turning centers or been around them for years. They're powerhouses, the QT200 or the QTS200. But it doesn't have all the sophisticated features. So the operator is constantly adjusting for growth when we're making parts to tenths on that throughout the day. So when they start in the morning and run the first part, it may have grown by half a thou. They have put in a half thou of adjustment by the end of the day. So, but with the milling center, we haven't had to ever do that. And so like DMG Moris have cooled ball screws. I think the higher end Mazaks have liquid cooled ball screws. But that's the next caliber of machine. And when you're buying some of these just vertical milling centers that don't have the liquid cooled ball screws and don't have some of the more advanced features built into the casting that the higher end machines do, it's that thermal compensation really makes up for it in a big way.
Yes, using software instead of a mechanical solution.
Absolutely. Yeah, it's been cool. It's the first one it was the first Mazak we bought, and that was the coolest feature, one of the coolest features by far. And to be able to produce parts of that tolerance, it's been a real game changer for us.
There is a Formlab 3D printer at your shop as well. Was that something you brought in at the get-go, or you added over time, and why a 3D printer?
It was one of the few pieces of equipment we added in the beginning. It helps for prototyping. We use it for fixtures for scanning. When we're reverse engineering parts before they get manufactured through subtractive manufacturing, we'll make them an additive. It's a lot less costly and not nearly as time consuming as going through the process of making a part on through traditional means. So it allows us to quickly prototype and check fitment of parts, check geometry, make sure there's no interference issues before we go into full scale manufacturing with it. Also, it's come in handy like when we needed to make the spider for that Lovejoy coupling.
Right. You have a lot of fairly sophisticated technology in your shop, and a subject that I'm always curious about with job shop owners is, how do you learn? How do you stay on top of technology and make sure that if there's something that will really benefit your shop, that you know about it so you can try it out and then bring it in-house if it makes sense?
I'm passionate about this stuff, so I'm always looking for the next best thing, if you will. We're like right now we're looking at 3D metal printers, and we're looking at multitasking mill turn 5-axis mill turn machines. We're always looking at the new tech and how it's affecting the market and what that means. With the advent of 5-axis simultaneous machines and these metal 3D printers, it's changed the way that people design and things are engineered completely. So, I mean, it's almost a necessity these days to have one to be able to stay competitive in the market.
So, for example, the 3D metal printer, how do you get your information? Do you read blogs? Do you read online? Do you talk to people? Where do you talk to people? I really want to understand, Ali, how you make that happen.
Yeah, so I'll absolutely read blogs and read as much information as I can online, and stay pretty attached to the forums and Reddit. And then on top of that, we have 3D Systems is not far from us, so they're always hosting events that we go to, and staying up to date on the latest and greatest tech, and going and interviewing with, or not interviewing, but rather inquiring about the equipment any chance we get. Speaking with engineers at these firms, or really in aerospace or racing, is a great lead on what's coming down the pipeline. So if you look towards aerospace and racing, typically what equipment they adopt is going to become mainstream at some point. So kind of looking to them and then going and doing some research about that equipment. My background, well before I got into manufacturing, was design engineering for racing. So that's how I came into the 3D scanners.
Before you learn how to use 3D scanning technology?
Yep. Yeah. Reverse engineering components for race cars, whether they're NASCAR or a GT or just autocross.
So at Rapid, one of the things I was always encouraging the team to do was automate what I called the rote tasks. things that people did over and over, but didn't really add any value. What manual tasks do you and your team do that drive you nuts and you wish there was an automated solution, or maybe there's some things that you've found an automated solution for that perhaps most shops you don't think are using?
So for us, it's the obvious one is deburring, right? Everyone wants to automate deburring, and then just manual part loading, and set up and tear down. Work holding is a big one. We'd like to come up with a better universal solution for work holding. The thing with us is we don't really do high production runs, so it's hard for us to automate the actual manufacturing process too much. That's why we're looking into the multitasking machines like the Integrex that really have the ability to make parts in one op and perform almost every operation that you would need on almost any part. So things like that will really help automate just the general flow. With paperless parts, we've been able to automate the quoting process, and it's also been our kind of our job tracker. So it's keeping us in line whenever someone orders expedited parts. We use the lead times of that to determine priority, and just pretty much whatever we can, really use macros for our software to try to speed up the mundane daily tasks.
Those are things that you can do in-house. What are things that customers can do to make it easier to work with you and make life easier for them?
The best thing we can ask of our customers is to just provide as much information as you can about your particular project. That'll really help speed things up. We like for our customers to utilize our RFQ system on our website. It really helps speed up the quoting process for us, and it keeps everything in line with the customers as well.
Why, if I can interject, why use the RFQ website, the RFQ form on your website, as opposed to just emailing in a RFQ to you?
Because it automatically it takes one step out of the process. So it generates the quote for us to review on our side, rather than waiting for a human to take in your information, build the quote, input the information, and then generate a response. So by helping with that, by having the customer help with that, they're helping themselves get a faster quote and helping us build a more accurate quote.
That's really cool. So this was a super conversation. Where can customers get more information about Mammoth Machine?
We ask that they reach out to us direct, info@mammothmachine.com. We respond quickly, and we respond to anyone that has a question. Anyone that has a quote or has would like a quote is more than welcome to drop it in, and more than likely myself or George will reach out to you direct. George and I really take pride in working hand in hand with our customers.
So your website address is mammothmachine.com?
Yep, mammothmachine.com.
Any other social media where people can find you?
Yeah, we used to be more active on Instagram. We really need to be more active on there, but feel free. We still check it regularly, so send us a DM on Instagram or quote or follow us.
Any last words for our audience?
No, thank you for listening and taking the time to speak with me and Mammoth.
Yeah, I learned so much about scanning. I was more familiar with it from about 10 years ago, and I know it's changed a lot, and you definitely illuminated some of the ways it's become easier, but it's definitely still as much art as science, and perhaps there's an opportunity there for companies to take the road out of the process and continue the automation. So thank you so much, Ali, for your time. I wish you and George and the rest of the team the best of luck. And for the audience, I hope you enjoyed the conversation today on the Job Shop Show. If you know of any other innovative job shops who you think would be of interest to our audience, please let us know. Thanks for listening, and keep those spindles turning and presses cycling.